Stealing PIN codes is easier today than ever before. Mark Rober on his YouTube channel warned of one method that is highly successful and is available to anyone through your local mobile phone vendor. Traditional methods for obtaining a PIN require watching or filming the sequence as it is entered. However, according to Mowry, Michaelajon, and Savage, a single thermal image of a plastic or rubberized keypad has a high probability of not only revealing the specific keys, but their sequence as well. What if your security didn't rely on a keypad at all? Techno Professor from Instructables.com presents the inspiration for this project. In this system, an ultrasonic sensor is used to convert distance measurements into numeric input. This has the advantage of having only a single input device, which would leave no useful thermal signature afterward. This system uses one ultrasonic sensor to measure range, a range ruler to display character positions, and a surface to reflect sound. LEDs provide indication while code entry is in progress, and a servo operates the access gate. Two push buttons are also used. The yellow button is the shift key and provides access to the bracketed characters on the range ruler, and the red button repositions the gate to the closed position. Finally, the National Instruments MyRio controls the system. These are the physical components that make up the ultrasonic-based access system. The code that controls this system operates as follows. Two loops run simultaneously. The lower loop calculates the time in microseconds. The ultrasonic sensor's pulse is returned. This data is written to a global variable for use by the upper loop. The upper loop consists of a sub-VI that converts the echo time data into numeric values, case structures that control program flow based on numeric input, digital outputs to the LEDs, and pulse width modulation output for the servo. The initialization for the program places system status in the locked and idle states, and any errors are handled by a reset. While locked and idle, the program is looking for a distance measurement less than a specified value, in this case 10. While in idle, all elements in the code entry status array as well as the unlocked state are maintained false. Code array position, constant entry count, and previous entry value are initialized to 0. Duty value of 0.1 is applied to pulse width modulation output, and all LEDs are off. Reading a number greater than 9, the code array is initialized to 255 in all elements, and the next state is idle. A value less than 10 prompts writing the pin stored in the code text file to the code array. The next state is enter pin. In the enter pin state, the red LED is lit. This state compares the numeric input to the code value at the code array position and stores the result in the code entry status array. The numeric input is also compared to the previous recorded input value. If they are the same, the constant entry count is increased by 1. If the values are different, the constant entry count is reset to 0. When this counter reaches 7, the next state is entry accepted. Otherwise, the enter pin state is repeated. In the entry accepted state, the red and yellow lights are lit. The Boolean values stored in the code entry status array are converted to 1s and 0s, added together, and compared to 4. The code array position is increased by 1. If the previous code array position is less than 3, the next state is enter pin. If equal to 3 and the converted code entry status value is not 4, the next state is pin incorrect. For a status value of 4, the next state is pin correct. In the pin incorrect state, the red LED is lit. A false is written to unlocked, and the next state is idle. The pin correct state turns the green LED on and sets unlock to true. The next state, while set to idle, is unlocked, or true for the outer case structure. While unlocked, a duty ratio of 0.2 is applied to the pulse width modulation output to operate and maintain the access gate open. The green LED is lit, and the unlock status is dependent on the close button. If left not pressed, the gate remains open. Pressing the close button sets unlocked to false and returns the system to the idle state. So far, we have discussed how the system uses the numeric input provided. The numeric input is based on the echo time received from the ultrasonic sensor. To generate the echo time, the sensor is triggered, a response is received, and the value in microseconds is converted to units of distance. The value of 250 corresponds approximately to 1.7 inches and is used for presentation purposes. For each distance measurement, a numeric value from 0 to 4 and 250 is generated. Operating the Shift button adds 5 to the result. This allows 6 positions to represent all 10 digits and provide an idle position. Now that we've seen what this ultrasonic-based access system is and what makes it work, let's see it in action. The first thing to do is to set an initial code. In this case, it is 2468. Next, start the program. The deployment process is time compressed. While this front panel is not viewable by the user or any over-the-shoulder watchers, it is presented here to show the operation of the system. The sonar out indication shows the numeric input value corresponding to the distance from the surface to the sensor. The user estimates this value using the range ruler. The LED indicators on the front panel correspond to those viewable by the user. The system is activated when a surface is detected with a value less than 10. The red LED is lit, indicating activity. Sonar out reads 1, which corresponds to the position on the range ruler. The yellow LED indicates a value has been accepted and prompts the user to input the next value. The entered code 1234 does not match the required code 2468, and the system returns to idle. A second attempt, 0561, is also not accepted. Now for the correct code. With the correct code, the green LED is lit and the gate opens. The text file that contains the correct pin is located on the MyRio. This file can be edited at any time by the administrator to change the pin while the system is operating. The new pin is 1590. The red close button closes the gate and places the system in idle. Observe as the previously correct code is entered. The pin 2468 no longer successfully opens the gate. The system cycles a second time due to an erroneous reading of 3. In the event the system is activated by someone or something not intending to gain entry, the system simply cycles back to idle. Now watch as 1590 is entered. The gate is successfully opened by the new pin. And now it's time for a new pin. The pin must be 4 integers, 0 through 9, separated by a space in the text file. And this time we'll use 9462. Now this unique sequence opens the gate. The ultrasonic-based access system is ideally suited to defeat thermal-based attempts to clandestinely obtain PIN codes. This system requires few points of contact through which a thermal signature can be read, and the signature collected is meaningless regarding PIN discovery. In the project presented here, one potential weakness is the use of a shift key. If the PIN contains no integer value greater than 4, the shift button need not be used. This reduces the possible number of combinations from 10,000 to 625, that is 10 to the 4th power to 5 to the 4th. If the shift key is pressed once, or even touched, the maximum number of possible combinations is preserved, as a thermal signature on a button that may or may not have been pressed at some point is nearly meaningless. To facilitate contact with the shift button, a security product could incorporate the button into an integral movable surface on the device. This would provide a single point of contact for any user with maximum security regardless of PIN characters used. Other limitations exist for any range-based access system that must be addressed to permit the product to be widely marketed. For example, the system presented here relies on the user to be able to see ranges and indications. A modern keypad-based system incorporates tactile markers on at least one key to provide orientation to the user. A tactile system could be incorporated into the movable surface, and audible indication could be used in conjunction with the LEDs. This concludes the presentation of the ultrasonic-based access system. Thank you for watching.